Okay, yes, here's part of the problem we're having that some of you are doing right now. Okay, here's part of the problem. We start writing down right away. We just start writing. And we have no idea where it's going to end up. Okay, we're just like, oh, reflexive. Angles are congruent. We just start writing and writing. We don't have a plan. Okay, that is part of the issue right now. So before we start any proof, we're going to figure out what the method is before we start. Okay, instead of just writing out step 2, step 3, step 4, step 5, and hoping, crossing our fingers at the end, we'll have something that goes. All right, so let's make a plan, please. BD and AC, those are what in the right triangles? What? Whoa, where are they across from? The right angle, so what do we call them? They're the hypotenuse, so I have the hypotenuse. Is there anything anybody else marked on the diagram before you started writing? Which we should be in the habit of already. What else can you mark on your own that I am never going to mark on that diagram? What else should be marked on my diagram before I start anything? Here we go, 1, 5, Alexi. What else should be marked? Which is what? CB. What's that of both right triangles? That's called my leg. Now you have I know it's HL day, so it's probably going to be HL, but I still need somebody to explain to me, why don't I have side angle side? I have 2 sides in an angle. Why am I ruling out side angle side? This is what I mean by making a plan. Here are my options, side angle side or maybe HL, but why not side angle side? Explain to me why not. This is how I know you guys are going to start getting it. 22. This right angle is not in between those 2 sides, gone, and I'm not even going to get fired up again about using SSA. Okay, that's never an option. Why HL? Is it a right triangle? Do I have the hypotenuse congruent? Yes, that was given. Do I have a leg? That was my reflexive side, so this is HL. Everyone good with the plan? It's an HL proof. All right, so what do I need in there still? I marked my diagram beautifully. Some of the stuff has not gotten into my proof yet. All right, what have I already marked in there that's still got to get into my proof? 12. Finley, what do I still need to write? I marked it, but it's not in my statements. CB, congruent to CB. Reflexive. The H is in there. The L is in there. Here's where I got to take over and explain some things. Remember the note at the top? If you're going to use HL, what else do I need in my proof? These 2 are what type of triangles? You have to say the triangles are right before saying they're congruent. All right, so I need to put triangle ABC and triangle DCB are right triangles. This is only for an HL proof. I need this in there. Not right angles, right triangles. Okay, so before saying they're congruent by HL, the step before, tell me they're right triangles, because why do I require that? This is the only type of triangle that can happen in. And then my reason's going to be, you guys can probably tell me, how do I know these are right triangles? I don't want you're sitting in. How do I know you're sitting in a chair? Definition of a chair. That doesn't tell me anything about a chair, right? How do I know these are right triangles? What's the dead giveaway here? They have right angles, right? Right triangles have right angles. Wait a second. Do you have right angles already in your proof? You have them in your diagram, but I don't grade your diagram. I grade your proof. Do you have right angles in your proof? Yes. Yeah, where? It was given. Okay. If they weren't, I'd have to write the right angles. All right, so I have the H, I have the L. You told me the right triangles. We're good to go. Step 4, we're done. Now the triangles are congruent by our new method. HL. Hypotenuse, leg. Only in what type of triangles? All right, if you don't see a right triangle, it's not, now you're down to the 4. Okay, now you're down to the old school 4. If it's not a right triangle. All right, anything you want to ask, because this next one is the longest one we're going to do all year. All right, buckle up. Whoa. it. Go ahead, mark your diagram. Go ahead. I'll let you mark it. Don't write anything, though, because, again, we got to make a plan now. Have a plan before you start writing statement 2. A lot of givens, huh? What's that symbol between AE and BD? What's that symbol so I can mark my diagram appropriately? 12 again. Finley, what's that symbol? So what are you putting on your diagram for this symbol? Right angles. Yep. Now look, don't get all nuts. Just because you put a right angle doesn't mean HL. We know that. Could be any method. BF and DE. How about that, huh? BF and D, however you want to mark that. BF and DE. AB and CD. All right, let's make a plan together, please. Let's make a plan together. First thing, look at the proof statement. What do you ask to prove here? 1 congruent to 2. 2 days ago, we talked. 1 will never be congruent to 2. 1 will never be congruent to 2 unless what's congruent first? What's got to be congruent first before 1 and 2? The triangles that contain 1 and 2. This is going to be a CPCTC at the end. But 1 and 2 will not be congruent unless the triangles are. What triangles? Name them. Name the 2 triangles that have to be congruent before 1 and 2 are. Zoli, which 2 triangles?
It's CFD and
BFC?
No, it's CFD.
Yep, and
AEB.
Yep. So I got to get those 2 congruent. Why those 2?
The triangles that contain
1 and 2 are in those triangles. So if those triangles are congruent, 1 and 2 are congruent by CPCTC because they're corresponding parts. Everyone see the plan? Get those 2 congruent to say CPCTC. All right, how do we get them congruent? Well, I already have what? Pair of sides in AB and CD. I have the right angles. All right, we're off to a good start here. Here's the problem, though. Everyone look at this given. BF and ED. Are those sides in the 2 triangles I'm trying to prove? Are those one of the 3 sides? Whoa, guys, look at the darn diagram. Is that a side in one of the triangles? This triangle, is that one of the sides? Triangle ABE. That's one of the triangles we're trying to prove congruent. Is BF a side in that triangle? No, it's much longer, isn't it? It's not a side, but I can use it to get a side. How? Something we have already done, and this is why these proofs are going to get a little bit more complicated. How can I get BF to be a side in triangle ABE? I can do it, make it shorter, subtract it. What am I going to have to subtract from it? I'm going to have to subtract EF from it, right? All right, so first step, I'm going to do a little subtraction, but I need to say EF is congruent to, what am I going to subtract on the other side to get DF? EF again. You need 2 pairs to subtract, and we only have the 1. So reflexive, but hey, everyone is understanding when I write reflexive, I'm not talking about a shared side here. This isn't a side shared. This is going to be a side. This is going to be a segment I subtract. All right, let's see if you have it or not. Show me what I'm subtracting now. Write down. Tell me what to write down to subtract. Ooh, on fire. Lily, not here. 5. Here we go. Jared, what am I subtracting? BF minus EF. And what was the other one? Sorry?
DE minus EF.
DF minus DE minus EF. Good. And that is subtraction. I need to do the subtraction to get the sides. What always comes after subtraction or addition? Substitution. And what 2 sides now are going to be equal by this substitution? what two sides? Ooh, there we go. Getting to hear from other video. What two sides?
BE and
BE. What was the other one?
FD.
FB, the bigger one?
Oh, FD.
FD, thank you. All right, so let me clean up my diagram for everybody. These are the two ready? These are the two triangles we need to get congruent to say 1 and 2. So you guys just proved to me BE is congruent to FD by the whole subtraction business. We already knew AB was congruent to CD. And we had these right angles I was told to put in. So that's what I have. Side angle side. I see two sides and an angle. Tell me why this is not side angle side. One more time. 3. Stella, why isn't this side angle? The right angle is not in between the sides. So that's why side angle side is ruled out. All right, next question. I still need a method here. Finley, in this right triangle, what's AB called? That's the what? Hypotenuse. What's CD called over here? The hypotenuse. So everyone see I have the hypotenuse congruent, and by subtraction substitution, the legs are congruent. So does everyone see HL here? See the H and the L. All right, but I'm not ready to write HL. What do I always need to say before I write HL? We did it in the last proof. What do you need to tell me before you write HL? 7. Drew, what do you need to tell me about the triangles? That they're right triangles, right? But I can't even do that yet. How do you know they're right triangles, Drew?
Because with the perpendicular lines,
Well, what do they have in them?
right angle.
Right, they have right. Your diagram has it. Does your proof have it yet? Did we say we have right angles in the proof yet? Nope. So that's what we need to say. It was given to us last time, so we didn't need to worry about it, but now we do. So angle AEB and angle DFC are right angles. That reason's not going to change. Perpendicular lines form right angles. And I'm surprised nobody asked me this in the last proof. Usually, what's our go-to next step? Always. It's always been what our go-to next step after telling me they're right angles. Usually you tell me they're congruent. Why don't I need to do that in an HL proof? What's the H stand for? And the L? Did anybody mention an angle? No. Okay, so HL proofs only, I don't need to say the right angles are congruent. If you happen to do it because you're just in that mode, it's not wrong. Just an extra step you didn't need. Okay, I'm not going to mark it off if you happen to say the right angles are congruent in an HL proof. Okay, I won't mark it off, but it is not needed in an HL proof. All right, what do I still need to say about the triangles? Still didn't write it down yet. 9. Vinny, what do I still need to say about these triangles? And I'm not ready for that yet.
They're right.
They're right triangles, yep, because I'm going to use HL. So triangle AEB and triangle DFC are right triangles. How do we know they're right triangles? For my reason, how do we know they're right triangles? Lauren? Right triangles have right angles, yep. Now you can tell me they're congruent. Okay, you had the H, you had the L. You told me they were right triangles. Now tell me they're congruent. I just need a good statement now. What do I mean by a good statement? Something that matches up your sides and angles. Tess, got that statement for me? Triangle. HL. And then we remember, this is why we had a plan. Prove those triangles congruent. So I could say angle 1 congruent to angle 2. And what's that reason after? to say the parts are equal. Finish it off, Makai. Nice order of the letters. Eight steps, longest one of the year. Okay, you got plenty of time here. I'm giving you 2 here. There's not many HL proofs I could find.